Okay, so last thing about heat of reaction is that we sometimes call it, or frequently call it, delta H. And that's because it's the change in heat. Remember, we said it's the difference between where you started and where you ended. It's your net gain or loss. Like, what was the difference between where you started and where you ended? Did you profit or did you lose money? Or did you lose or gain energy? So what we find is we can either have a positive or a negative delta H. So think about it. If you are exothermic, that means that you released energy. So that really means you operated at a loss. So is your delta H going to be positive or negative? It's going to be negative. You went down in money or down in energy, okay? The difference between where you started and where you ended is a negative number. It's like this is a bigger number than that. And then this one, endothermic. Endo means energy went in, energy was absorbed or gained. So we want to show like a gain of profit. Like you started here, your reaction happened, and you ended up here. And so overall, between where you ended and where you began, there was an overall maybe gain of like $20 or 20 kilojoules of energy. All right. So you're going to have to know that negative delta H is exothermic and positive delta H is endothermic. All right. And you're going to have to be able to look it up on this wonderful new table called Table I. And Table I is just a list of different heats of reactions of common reactions. So here's Table I, and it's just a list of common reactions, either things burning or things dissolving or ions getting together to make something else. All right, so you'll have to look up the delta H and maybe find the number like over here and decide if it's endo or exo. So all these negatives are going to be exo because they're operating at a loss. Energy was lost, energy exited. And all these positives are endo. And you do have to know that. But lucky for us, right here at the bottom of the table, it does say right in the reference table below it, a minus sign indicates an exothermic reaction. So you don't even have to memorize that. It is written right there. Okay. So you might be asked to like look up one of these numbers. So let me give you an example. So it might say, what's the delta H for forming 2CO2 from CO2, from CO and O2? So you just find that exact reaction. There it is. There's me making CO2 from CO and O2. What's it cost? It costs negative 566 kilojoules, meaning like it operates, that reaction happens with a loss, a release of 566 kilojoules of energy. All right. And then they might ask you something, well, what if you needed twice as much carbon dioxide instead of making 2 CO2s? What if I was trying to make, say, 4 CO2s? Okay. What if I was trying to make 4 CO2s? Well, if I'm trying to make twice as many CO2s, it's going to take twice as much energy. So all I do is take that number and multiply it by 2. All right. So I would take this number multiplied by 2, and I think I get like 1132 kilojoules. All right. So that's one thing you might have to do is like maybe double the number or have it. The other thing is you might be asked the reverse of reaction. So they might say, find the delta H for the dissociation of CO2. So I'm looking and I'm like, I can't, that's the breaking of CO2. I'm looking, I'm like, I can't find the breaking of CO2, but I can find CO2 being formed. So maybe I could use that. So unfortunately, I just crossed that out. So for CO2 to be formed, it costs negative 393.5 kilojoules of energy. So then I'm like, okay, well, if you lose that much energy to make CO2, then it must be that the reverse, breaking CO2, is the opposite. So instead of being negative 393.5, all I have to do is flip it to positive 393.5. So if you find that you have to flip a reaction, then you're going to flip the sign on the delta H, right? That kind of makes sense, right? Okay. Other thing they might ask is just like, well, then what if you had 2.3 moles of CO2? And it would just be take that same number and you're trying to make 2.3 moles, you would take that 393.5 number and multiply it by 2.3. All right. So looking back, what we have to know is that the negative delta H means exo, positive delta H means endo. You have to be able to look them up, and you have to know that you might have to